And everyone else is free to, please come up, Godfrey Decorer.
Round of
applause again. Thank you.
Okay. Huh? Yeah, but might not need them. Okay. Right. 1 second. So in 2016, when I was in Zimbabwe, one of our 3 cows, Shumba, fell sick. She spent 2 days without eating, and the nearest vet was 80 miles away, a distance that could have costed us our entire monthly savings. Shumba wasn't just a cow. She was our milk, she was our growth power, she was our income. We tried everything we could, traditional remedies, we asked neighbors, but unfortunately, Shumba died. This was the beginning of an epidemic disease that has since killed 500,000 cattle in Zimbabwe, and that's $250 million wiped off smallholder farmers, pushing them down into poverty and hunger. Most of these deaths are preventable with just a $2 drip treatment if farmers know what to do and in the right time. Globally, livestock disease destroy 20% of production every year. And for the smallholder farmers that support 35% of the world's food, they're suffering the same fate. A sick animal, no vet nearby, no sure what to do until it's too late. And that's why we are building VVET, a livestock intelligence health system. This will allow smallholder farmers to use it through SMS, through WhatsApp, through USSD, through VVET mobile application, either with or without internet. Now let me show you a glimpse of it using WhatsApp. Now it's 2016, Shumba is sick, but now I have VVET. All I need to do is to record Shumba's symptoms, explain Shumba's symptoms, and in the background, and within 60 seconds later, I get the diagnosis. What's wrong with Shumba? I get the context. When was Shumba treated? Who treated Shumba? And what was Shumba treated for? The AI remembers every consultation, every vaccination. And most importantly, I get the action. Now I know what's wrong with Shumba. What do I do now? What am I going to do with Shumba? While I wait for the closest veterinary health, animal health worker to verify the diagnosis. And at a glance, the system has 2 main categories. For farmers, they have an AI symptom triage, they have a step-by-step emergency guidance, they have vaccination calendar and reminders, individual animal health profiles. And for the vets and the government, they have dashboard with the full animal history, fast escalation, real-time disease surveillance map, outbreak data for police decisions. We are not replacing animal health workers. We are giving them superpowers. We are accelerating diagnosis. We are capacitating farmers so that they'll be able to prevent this disease. They'll be able to save their livestock. And for the smallholder farmers, these livestock is their entire income, is their entire livelihood. Obviously, you might be asking, what about the existing solutions? Most of the existing solutions are for commercial farmers, not for the smallholder farmers. There is smallholder farmer solutions that exist, but for example, iCow in Kenya, it has 600,000 users, but it only works on SMS. It doesn't have AI diagnosis. It doesn't have voice and local language. It doesn't have contextual memory, and it doesn't have an outbreak prediction. Same for Danga in Zimbabwe, same for EVET. No platform combines this for smallholder farmers, and that's the gap. So what's the missing piece to build this system? A DGX Spark, a 1 petaflop supercomputer that can calculate 1 quadrillion calculations per second. And it provides a list of endless capabilities that we're going to need. For example, video analysis for tick detection and for skin lesions, and translation for local languages. This system is a monster, a pocket data center. But most importantly, we're going to use it for 3 workloads. First, we're going to fine-tune a llama with 70 billion parameters using quantized LoRa technique to train veterinaries using structured and unstructured data from veterinary schools, from government, from NGOs, so that this vet llama will be able to understand local languages, local dialects, local diseases, and local animals for the smallholder farmers. And second, a localized whipper, because most of the smallholder farmers, obviously, they don't want to type, they want to speak, and we're going to fine-tune a whisper modem. And third, a geospatial neural network. It's going to uncover the hidden properties, the hidden patterns, so that we'll be able to predict where the outbreak is going to hit next, using several variables, including GPS location, symptoms, diagnosis, season, rainfall, and tick patterns. And for every data, for every consultation, for every livestock, we're going to retrain, we're going to run inference at scale. So, at first, we're going to pilot in Zimbabwe, where there are 4.5 million cattle, but they don't even have a single mobile application, a single AI system that is working to save the 500,000 animals that are being lost as we speak. And we're going to scale to Southern Africa, East Africa, and the rest of the continent. And we're not going to stop there. We're going to expand to cattle. We're going to expand to goats, sheep, poultry. And the main objective, to create Africa's first real livestock health intelligence system for the smallholder farmers. Now, back to Shumba. It's 2016. We're sitting there in our village and she's sick, but we have Vivet and we're able to save Shumba. That's what we're going to build with the DGX Spark, not for the industrial farmers, not for the high-benefit cities, but for the 500 million smallholder farmers around the world that are feeding the world. Thank you.
Brilliant job. Thank you so much. And I love how these...
So we're going to be looking into...
And this is the human... So if you feel like you want to get expired...
So I'm Vedan. I'm currently a placement student, tracking and detection for conflict analysis from footage.
I love the overlap and the consistency. So, if you need color printing, someone to go to.